Okay, section 2 for chapter 9, we are classifying chemical reactions. So I just counted this, but I think there's 6. 1, 2, 3, 4, 5. There's 6 that we're going to talk about, and then there's a 7th one that actually can be classified as other reactions.
Yeah, but we're going to give that a whole video on
its own.
Yeah.
Okay, so let's get started with talking about states of matter. Now, you will notice that in the equations that I'm giving you, you're going to have state of matter listed afterwards. So a small s, these will be subscripts, but a small s means solid, G means gas, L means liquid, and AQ means aqueous. And section 3 is all about aqueous solutions, so you'll learn more about that. Synthesis, first type of reaction. So it's a chemical reaction in which 2 or more substances react to produce a single product or one product. Okay? Notice this is written in your notes, but you have A plus B yields AB.
Okay.
For an example, you have a blank spot there. So I would write in this equation, you've got solid sodium plus chlorine gas. Notice chlorine gas is a diatomic, so you have Cl2. Now you need to go through and balance. Where's my pointer? Somewhere. Oh no. We did that last time too, didn't we? Okay, so let's look at sodium. You've got 1 over here, 1 over here. Chlorine, 2, so you need to put a 2 in front of this sodium. Now you need to put a 2 here. Done. Notice it's solid, that's a gas, that's a solid. Okay, decomposition, when one compound breaks down into 2 or more products. So you've got one compound here, AB, and it's breaking down into A plus B. So you've got sodium nitride, Na3N. It is a solid. It's going to break down into solid sodium, so just Na, plus N2, which is a gas. So it's nitrogen gas. I was going to call it nitride. No, it's nitrogen gas. So make sure that you write this down for your example while we go through and balance. So
3 NAs.
Oh, geez. Pointer. Okay. Felt tip pen. Thanks. Okay, 3 NAs. So over here we need to write a 3. Okay, now what?
Well, and then we got to fix our N's because we've got 1 N on our reactant side, but 2 on our product. So we got to put a 2 there, which then changes our other one, which is why you're going to be doing this entire chapter in pencil.
Yes.
Because no longer is it 3, it's now 6. So we have a 2, 6, blank.
Okay, and some people would maybe try to reduce this one, but you can't because you got a 2, 6, and technically a 1 here, so you can't reduce them all.
Yep.
Okay. Combustion. This is when oxygen combines with a substance and releases energy in the form of heat and light. So there are other combustion reactions, but we're going to deal mainly with hydrocarbons, which is where carbon is bonded with a hydrogen. So that's why it's written as CXHY. The X and the Y are just whatever your subscripts need to be. And then it's paired with oxygen gas, and it releases CO2 gas and water. Okay, so an example that you can write down would be methane, CH4 plus O2. That's oxygen gas, and it's going to yield carbon dioxide and water.
Okay.
Now, this nice picture has already balanced it for you so that you can tell that you have the same number of oxygens on each side and same number of hydrogens and carbons. Okay, so if you need more time, pause, write this down. Moving on. Single replacement. So atoms of one element replace the atoms of another element in a compound. So what you have written is A plus BX yields AX plus B. So both of these are going to be positive ions. Will they always be ions?
No.
Okay.
Because we could have a negative, we could have a gas also trying to kick out, because we can
That's
also
true.
use our halogens.
Yes. So if you're dealing with it like this, these are going to be mostly your metals trying to kick each other out.
Yeah.
But if you've got a diatomic molecule or a gas and it's trying to kick out a halogen, then it would just be you would just have your X replacing the B.
Yep, we'll get to examples.
Yeah, we will.
So let's give you one example. Let's do
Zinc?
Sure.
Okay, zinc. If it's just zinc, it's going to be a solid.
How do you know that? You're going to look on your periodic table.
Yes.
And you're going to look
Oh,
at
yeah.
what is it at room temperature. So you would know if it's a solid, a liquid, or a gas. There's
Mhm.
really only 2 liquids on here at room temperature.
Right.
So take a look at your periodic table and use that.
Okay.
And silver chloride, how about that?
Okay, so we'll pair it with silver chloride. So silver is one of the funny transition ones because it only has one charge. It's a +1. And then chlorine is -1. So it's just AgCl.
And for these, those are going to be aqueous solutions, so we can try to bump something out. You can't make a circle.
I know it. Okay, and we'll talk more about aqueous, but for right now, just write the AQ on there.
All right.
Okay.
So in a single replacement, you have to actually look on your cheat sheet.
Mhm.
And we're going to look at what is called an activity series.
The next slide talks about it.
Oh, you're jumping. Oh, man.
You're
I'm getting
jumping ahead.
All right.
Okay, for right now, let's just ignore this whole thing called an activity series. We'll get to it. So right now,
Trying.
you've got a positive zinc right here, and it's trying to bump out this silver. So you're going to rewrite your equation. You're just going to replace the zinc with the silver with the zinc.
So it bumps out the dance partner.
Yes. So this one is going to go here,
So
and silver is going to go out.
if it's a positive, it can only bump out the other positive.
Yeah.
If it's a negative, it could try and bump out the other negative.
Mm-hmm.
All right.
Okay, so zinc has a +2 charge, and chlorine has a -1, so it's going to be ZnCl2, and this one is also going to be aqueous.
Yep.
Okay, and now you're going to have silver by itself.
Oh, poor guy. Got kicked to the
So
curb.
now it's all lonely or happy if it didn't like chlorine. Okay, so let's talk about this activity
We
series.
didn't balance that, though.
Oh, we haven't balanced. Let's balance. What do
That's
we need
easy.
to do?
So zinc and zinc are good.
Okay,
Ag and Ag are good. Our chlorines are not so good.
so 2 here,
Yep.
2
Yep.
here.
Done.
Okay, activity series. This orders metals by reactivity with other metals. So a metal will not always replace another one. So sometimes you may end your equation with no reaction or NR. NR means no reaction. Okay, so the most active ones are at the top of the list. The least active are at the bottom. So the ones that are least active are not going to replace the ones higher than them.
I like to think of these as the big dogs can kick out anybody underneath them. So if they're the little guy at the bottom was dancing luckily with a pretty girl, and the big dog came along and kicked the little one to the curb. So here, let's look at what our example was. We had zinc, and we were going to see if zinc, the single element, could kick out the other positive piece from our compound, which was silver.
Yes.
Zinc is above silver in our
Uh-huh.
activity series, so it can kick it out and make a reaction.
So zinc would kick out silver, but if silver were by itself, it would not be able to bump out zinc.
So we would write NR
Right.
on the product side.
Okay. We'll get practice with that. Now let's talk about double replacement. These are positive and negative ions of 2 compounds. They switch places. So this is when everybody does their little
do-si-do.
yes. They trade partners. I thought I was the only one who said do-si-do. Okay. So notice you've got AX plus BY. Now you're going to go AY plus BX. So give me an example.
Oh gosh. Let's do lead nitrate.
Okay.
I know we're going to give you a big one.
What?
PbNO3 parentheses 2, and these have to be aqueous for this stuff to happen. So each of your reactants are going to be in the aqueous form for these.
Okay.
And let's do sodium chloride. So NaCl.
Aqueous.
Yes.
Okay, yields. Whoa, that's a terrible one. Okay.
So the positive and the positive are going to switch who they're dancing with.
Okay, NaNO3.
Yep, because Na is a +1, NO3 is a -1. They cancel charges.
This is a
And
nitrate,
we're
so
going
it
to
would be aqueous, correct?
Yeah.
Okay, and then we've got lead.
Pb chloride.
Okay, so PbCl2.
2. Yep,
Because that was lead 2 over here.
yep, and that's going to be a solid.
Yes.
Which we
Now-
will talk about on how how we know that this is aqueous or solid
Mhm.
is in section 3. So don't be too worried about that right now. We'll get to how we know it's aqueous or solid.
Okay, do we need to balance?
Oh,
yes. We've got 2 nitrates over there, so 2 here,
Mm-hmm.
2 sodiums.
2 sodium,
Now we got 2 chlorines.
2
chlorines.
chlorine.
We got 1 lead, 1 lead.
1 lead.
We're good. So if you can make out what I wrote there, please write this in your notes, because that is a good double replacement reaction, including the polyatomic ion.
All right.
Okay? Acid-base reactions, when an acid and a base react to form salt and water.
Now, salt is any ionic compound.
Not
And
just NaCl.
we know that something's going to be an acid when H is at the beginning. You should know this because we named acids all in chapter 8. And something's going to be a base when it ends in OH.
What do you want to start with?
HCl.
Okay.
And let's do
Sodium hydroxide?
Yeah, sodium hydroxide. Why not?
This one is easy, and you will see it over and over and over again.
So now what's going to happen is it acts just like a double replacement. The positives are still switching dance partners, so it would end
so
up
the
being
sodium and the hydrogen switch spots.
So it'd be NaCl,
That's your salt.
and then technically if we were to write this it'd be HOH, but you know this as H2O. And everybody in this had a 1-to-1 charge, 1 positive, 1 minus, so everybody works out really well.
We've got 2 hydrogens here, 2 here. So really it's HOH, but you would write it H2O. Okay, that is all for section 2. The next video will go on to a different type of reaction or different way of classifying it. But that is all for 9.2.